Hey everybody, so today we're going to start back up on number 36 and we're going to try to see how many I can get through these before I run out of time. So if you have not watched these before, in the video description you'll find a link to the digital platform in which you can take this exam. And if you have not done so already, I would recommend trying this problem there first so you get used to the interface and then come back here and watch this. So if you haven't done that, I'd recommend doing so. There's also a PDF available for download or print, which is what we're writing on right here. Okay, let's get right to it. Storage rack has two wires that help support the sides of the rack. Here's the wires right here. Each wire connects the top of one side of the base to the rack. Excuse me. The sides form right angles here and here with the base of the rack. The rack and its interior dimensions are shown in this diagram. Okay. Which of the following is closest to in length of each wire? All right, so let me see if there's I can't remember if there's a calculator on this one or not. Let me double check. Okay, there is a calculator for this one, so that's good. All right, so that'll make it a lot easier for everybody. All right, so we're looking for the length of the wire. So we're looking for this length here, because these are both supposed to be the same. All right, well, we see that it's part of a triangle, okay? And specifically, it's part of a right triangle. And we're given two of the legs, which means we can find the third missing side here by using what we all know as the Pythagorean theorem, right? So a squared plus b squared equals c squared. This is actually on the reference sheet too. So if you click on the exhibit button on the right-hand side of the screen when you're taking this, it'll pop up and Pythagorean theorem's on there. Okay, so we know the c is the hypotenuse, so that's what we're looking for. We can just label these as a and b, doesn't matter which is which. So we're going to do 12 squared plus 6 squared equals c squared, and we're solving for c. So 12 squared is 144, and 6 squared is 36, and we don't know what c is yet. 144 plus 36 should be 180 equals c squared. And we're going to do the square root of both sides because we want c, we don't want c squared. And if you use the calculator that's part of the test, you should get something that's quite close to 13.4-ish. Goes on, basically. So something very close to that, I'll show you. So 180, actually, oops, hold on a second. Square root, 180. Oh, it's doing that. Hold on one second, I gotta fix that. So if you're ever using these calculators, might as well show you. If you're ever using these calculators that's coming out with the simplified radicals, just press the mode button, and then go down to here, and you want it to be on classic. Math print will simplify the radicals, classic will just give you decimal, okay? So, fun tip there. So yep, I already did that. So you can see it's closest to 13 and 4/10. It goes on forever because it's an irrational number actually. So that's gonna be part C, or letter C rather. So again, this is really just, hey, do you know Pythagorean theorem? Do you know how to use it? And that's what it comes down to. So we should all be pretty good there. All right, 37. And this is a multi-parter. Okay. This table shows the linear function f of x for different values of x. A student graphed the line that represents f of x in a coordinate plane. Select true or false for each statement about the graph of f of x. Okay, the first statement is the slope of the line is positive. Slope is also known as the rate of change. Oh, by the way, for the previous one, that's definitely one you want to be using your scrap paper on, as is with a lot of these. So rate of change. So as x increases, what's happening to y? Is the functional value, and y is the same thing as functional value. So as x increases, is the functional value going up or down? Well, let's see. As x increases, which is happening here, the functional value is decreasing. So that means it's a negative rate of change, right? Which means this would be false. It's not positive. Okay. The y-intercept of the line is positive. Okay, so that means where it crosses the y-axis. In other words, when x equals 0, what is the functional value? Is the functional value going to be positive or negative? Well, let's see. We don't know what the functional value is when x is 0. We could figure it out if we really wanted to, but we don't even need to. Because look, when x is 2, the functional value is 223. And as we can see, as x increases, y is going down, or the functional value is going down. So it's safe to assume that the functional value when x is 0 is going to be higher than this, therefore it's positive. So yeah, this is true. Okay, so this problem, it really just requires to have a firm understanding of what linear functions look like and what a y-intercept is and what a rate of change is. And we also have to understand that slope and rate of change are the same thing. Okay? Let's look at the second part. All right. A student also graphs the linear function, so this is the linear function just as a graph format. Oh, there's a different one. This is g of x. Never mind. G of x on a coordinate plane shown as below. Okay. Write an equation for the function g of x. g of x equals blank x plus blank. So this is, write this down. This is going to be y equals mx plus b. No, why am I writing parentheses? Y equals mx plus b. All right. M being the rate of change or slope. All right. Well, I'm off screen. That's not going to help. There you go. And this is the y-intercept. Okay. It can throw people off because it's not a y, it's g of x, but the functional value is y. It's the same thing. It's the vertical axis. They just, see how we can confuse people. All right, so I would always start with the y-intercept. Honestly, that's where I always start. So where does this cross the y-axis? Right here, which is 228. Okay. Now the rate of change, we need 2 points, right? So we have a point here, and we have a point here. So if I take the vertical change and put it over the horizontal change, right? That should tell us our rate of change. So y2 minus y1 over x2 minus x1, right? So somebody's knocking on my door. Okay, so the rate of change form we have here. And let's go ahead and plug this in. So we're going to have x1, y1, and x2, y2. So our y2 is going to be 228 minus 0. And x2 is 0 minus 38. Okay. So 228 minus 0 is 228. Must be 288. And then 0 take away 38 will be negative 38. So we're going to do 228 divided by negative 38. We can do it right here. So 228 divided by negative 38, negative 6. So that's our rate of change. So there we go. So g of x would be equal to negative 6x plus 228. That's our rate of change. That's our y-intercept. Okay. So this would be number 38. We're almost done, guys. We're actually getting very close to finishing this. 38. All right. So a student has 2 part-time jobs, babysitting and tutoring. The student earns an hourly wage at each job. On Monday, the student earned a total of $130 for 4 hours of babysitting and 2 hours of tutoring. On Tuesday, the student earned a total of $80 for 3 hours of babysitting and 1 hour of tutoring. Which of the following systems of equations can be used to find x, the student's hourly wage for babysitting, and y, the student's hourly wage for tutoring? Okay, so x is babysitting and y is tutoring. Okay, so this is x, this is y, this is x, and this is y. So I'm going to go ahead and write this. So 4 times x plus 2 times y equals $130. That's the first one, right? Second one's 3 times x plus 1 times y equals $80. And I believe that is this one right here. Yep. There we go. So again, if you're using a dry erase marker, which you should be on this, or using scrap, I mean, this one I wouldn't use scrap paper. I'd actually do dry erase and then do the scrap paper here. But I would draw the x on top of this and the y's on top of that. And actually, I mean, the equations kind of write themselves, to be honest. So yeah, this is just really testing your ability to set up a system. You don't have to solve it. You just have to set it up. Okay, 39. I think this one's really challenging just because it's so poorly worded, and I'll explain what you have to watch out for, because this problem actually I found to be a little confusing just because of the way it's worded. So number 39, figure R is shown in this coordinate plane. So figure R looks like a parallelogram. Which of the following transformations would carry figure R onto itself? Now, this is why I found this confusing, because I didn't know really what this meant. Carry figure R onto itself. What they're trying to say here, and this is important because I may say this again, what they're trying to say here is what transformation would result in the image being identically placed to the previous pre-image, right? So when you apply a transformation, what's going to leave it where the resulting image is identical to the pre-image and located in the exact same spot. In other words, it doesn't look like anything happened. That's what they're saying. So if you reflect over the line y equals 1, which is a horizontal line rather, like this, it'll fold on top of itself, but it won't be entirely where it was. So part of it will be on top of itself, but it won't look like the same shape. So that's out. Similarly here, x equals 1 is a vertical line. It'll fold partially on top of itself, but it'll overlap, right? This part here, this part goes here. That's out. And 90 degrees rotation around the point, about the point 1, 1. So 1, 1's right here. We're used to rotating about the origin. So if you rotate this 90 degrees about where it is, it's going to rotate like that. It'll be a 90 degree turn. It won't be exactly on the same spot. However, this one, 180 degrees rotation about the point 1, 1, which is dead center of this pre-image, means you would rotate this 180 degrees, and it would be exactly where it was. So it's D. But again, you need to understand what they're asking here. And I found the wording to be quite confusing. So remember, if they use this wording, it means basically what's going to happen what would we do that would result in the image looking identical to the pre-image and being positioned in the exact same spot. I guess there's just a lot less words. But yeah, anyway, that's 39. Number 40. This one also you got to be careful. This one almost tripped me up when I was doing this one. So number 40. The population for each of the 4 towns is predicted to increase or decrease at a constant rate. The equations shown in this table can be used to predict the population P for each of the towns T years from today. So these are all linear equations, right? So Pine Hill is here, right? And you can tell it's going down by 20 each year. So you can kind of tell which of these is like the populations are increasing and which of these are decreasing if you look at these carefully. We have starting values, like the starting populations, and then the rate of change, okay? All right. This is kind of a neat problem because when you do this on the computer, you can like literally click and drag these into where they belong. So it's kind of neat. Okay. So they want us to determine which of these are increasing in population and which of these are decreasing. So let's go back and look again. Okay. So we're looking for positive and negative rates of change. So this is a negative rate of change. Pine Hill's going down by 20, so negative. This is a positive rate of change. It's going up, so it's positive. And this is so you be careful. That's the rate of change right there. It's positive rate of change. And this is a negative rate of change right here. Right? So Troy and Pine Hill have populations that are going down. Rye and Smithfield have populations that are going up. Okay. So Troy is going down, as is Pine Hill. And then Rye and Smithfield are increasing. Okay. And then this part's asking us to put them in order from least to greatest. So let's go back and look at our starting values. So if you look at these are the starting values, the y-intercepts, right? So you have to assume t is 0. When t is 0, which of these has which is the lowest population? So I'm going to just circle all the starting values. So that's the smallest one. So I'm going to put an order from lowest to highest. So 1 for Rye, and then 2 for Troy, and then 3 for Pine Hill, and then 4 for Smithfield. So we have Rye, Troy, Pine Hill, and Smithfield. Okay. All right. So that was number 40. Let's look at 41. Okay, 41 is asking us, they're telling us that a student shaded part of circle V as shown, and they're asking us which of the following is closest to the area of the shaded circle V. Okay, so we know if we want to find the area of a circle, we look in the formula sheet, which is in the exhibit area, or exhibit part. And this does have a calculator available, which is nice. It'll make our life easier on this one. So the area of a circle formula is A equals pi r squared. That's the area of a circle. So before we find the area of the sector, we need to find the area of the entire circle. Okay, so the radius is going to be 10. It's the distance from the center of the circle to any point on the circle. So r is 10, so pi equals 10 squared. And 10 squared is 100. So it's going to be 100 pi. So the area of the whole circle is 100 pi. Okay. Now we need to know what this sector is. Well, we can take the angle over 360 and multiply it by the area of the circle, and that'll give us the sector area. Okay, this is not found on the reference sheet. So the angle measure here is 90 degrees. 360 is the total, so 360 is here. And times the area of circle is 100 pi. And we just have to do that. So and 90 over 360 is 1/4. We can actually do this, well, most of it without a calculator. And then 1/4 times 100 would be 25, right? Okay, so you could do this without a calculator because it's saying closest to, right? So they don't see any pi's over here because what they did was they estimated the value of pi, which we'd roughly say is 3.14, right? 3 1400ths around there, and then obviously goes on forever. So a little more than 3. So 25 times a little more than 3 would be a little over 75, which is going to be option A. However, if you were to plug in, let's say, using your calculator, which is available, so you don't even need to estimate it, you could do 25 times 3.14, and look at that, 78.5, which is right there, okay? So again, you need to know the area of a circle formula, and you need to know how to apply, how to find a sector area. So sector, you just take the angle of the sector, put it over 360, and multiply it by the area of the circle. Boom, there you go. Last one, here we go, 42. And then we're all done, guys. All right, so a student will draw the line of best fit in the set of data shown in this scatter plot. Which of the following best describes how to draw a line of best fit to the set of data? So I would draw a line of best fit something like this. Somewhere around there, roughly, right? Okay, what a lot of students want to do is do this, but they don't necessarily have to, and actually would not have this go through the origin. The line of best fit should pass through the origin. Not necessarily, not in this case.